Okay, so the last part of lecture one here is talking a little bit about this thing we call risk and reliability. So risk is defined as the probability that the magnitude of the design return period, which is T, goes back to our return period we were talking about, is exceeded within a certain time, or the probability of at least one exceedance, right? So it's a little different than how we were looking at the examples earlier. So mathematically, we can define risk as this equation here. We've got, basically we've got the return period or the probability of that event in there raised to the total number of trials, right? So we could ask a question, and you should work through this for the lecture period, is what is the risk of having at least one event, so let's say a 100-year flood, in N years, maybe the next 5 years, right? So this is the type of question that we could answer with this. So this is a good example. You should take a minute after this and work through it and bring that to class. So how is this useful to us maybe in some other contexts? Well, let's look at the context of dam breach and dam safety here, right? So an example of where we might want to know risk, and this is a little different than what we were talking about with the equation, but it's an interesting example nonetheless, is this thing called the FN chart, right? And this is put together by, it's used by the United States, the Bureau of Reclamation, right? So in this graph, they plot the annual failure probability, F, so that's on the left hand, the y-axis here, against a life loss estimate, right? And so you could look, and say, okay, if this dam failed, how many people's lives would be at risk, right? So if it was a big city, you might have 10,000 people, in the way if this dam breached, and that could possibly lose their life, right? And we've got the failure probability, right? The risk of it happening at least once, the annual failure probability on the y-axis here. And what's neat about this graph is it's kind of unifying failure of infrastructure and life lost, right? And there's some action levels here. So these dashed lines, they indicate zones where action may be needed. It's called the annualized life lost. And basically these lines are simply the annual failure probability multiplied by the life lost estimate. And so if you get above 0.0001 of annualized life lost, there begins to become these thresholds where we need to start thinking about taking action to reduce the risk, right? And so those blue dash lines begin to indicate these zones where as engineers or managers, project managers, city, municipal engineers, government workers, we need to start thinking, hey, there's some risk to life here we need to consider, right? And so one thing to think about this chart is maybe, is this a good framework for assessing other infrastructure? Have you guys done this or thought about this in other classes? What else could we apply this to, right? We'll talk about that a little bit in class. So the last thing for this lecture is this thing we call reliability, right? And this goes back to kind of the cofferdam example, right? How reliable is my infrastructure? And reliability is kind of interesting because it's just kind of like the other part of risk. It's defined as 1 minus the risk, essentially. So this is pretty easy, right? So it's mathematically just defined as 1 minus risk, or if you kind of want a full-blown, version of this, it's 1 minus, 1 minus 1 minus 1 over t to the n, right? Or it can simply be defined as 1 minus p to the n. So however you want to think about it, but it's basically 1 minus risk. Okay, so this concludes lecture 1, and we'll see you in class.